Welcome back to the channel. If you don't know, I take simple code challenges, break them down, talk about how I solve them, and then hopefully along the way, especially if you're new to programming, you'll get some sort of knowledge out of this. Hopefully that will help you improve your knowledge, and if you're getting discouraged, hopefully this helps you continue your lifelong training and getting better as a programmer. So let's jump into our next one. This one is a Pangram validator. Go ahead and read it. The parameter will be one string consisting of under 100 characters. The parameter will contain spaces, it will contain punctuation, and there will also be uppercase and lowercase letters. We need to return true if the sentence is a pangram, and return false if the sentence is not a pangram. So the very first thing we have to do is, especially if we don't know what this is figure out what a pangram is. So as you're writing code, as you're getting an assignment in any way, understand what you're trying to do first. So let's look it up. What is a pangram? And this might help us out. A sentence or verse that contains all the letters of the alphabet. That might not be too useful, so you want to really understand what it is. So this actually seems a little better. A pangram is a pangram, or this other synonym for it is a sentence using every letter of a given alphabet at least once. Okay, so that makes sense. We also need some sort of test cases for it. So let's see if there are examples, and there are examples of pangrams. Here we go. So here's an example. It's a weird sentence, but that is a pangram. So we'll use that as our test. So that would return true. Apparently this would as well. And then if we just write something simple like that, that would return false. So here's our samples, here's our examples. So let's get into it. I already made a class. Let's make a static method that's a Boolean static method that's going to accept a string as input and return a Boolean value. And we'll call it is pangram. String, we'll call this sentence for our parameter. We'll save something, or I'm sorry, we'll return just true to make sure we can save it, and then we'll call it up here. That's how we'll call it, but we want to actually see what our value is, so let's print it out. If we use spacing, we can better see if we make errors or not. So in our static method, we're going to just print the value of the static method is pangram in the pangram class, and it should return true. Let's compile it. Let's run it. That's a long compile. Run it, and true. If we returned false here, it will return false. Not a useful program yet, but let's see what we could do. All of these sort of constraints, these are useful. We're going to need to make sure we understand this. But for now, let's go ahead and just loop through our sentence. We know that we're going to have to look at every single letter and do something with it. Keep track of the fact that there are potentially every single letter of the English alphabet accounted for. So we have to, at the very least, loop through our sentence. Let's do that. We just use the enhanced for loop. Really important here, we want to name this something useful, and I'm going to name it what I think would probably be the incorrect naming of this. We're going to loop through all of our letters, or sorry, we're going to loop through a sentence. And this sentence can actually contain spaces and punctuation. So calling this letter might not make sense, but let's name it that now, and then later we're going to name it something better. This is a misnomer now because this sentence contains spaces, punctuation. So this is actually sort of us adding, maybe not a bug, but definitely someone could look at this, assume that there really are only letters in here, and maybe make a bad choice programming later. Okay, that's how we'll loop through all of our letters. And if you don't know, this is the variable sentence is an instance of a string object, and the string object has an instance array, an instance method called toCharArray. Let's look that up. Java string class, we'll look that up. And in the Java string class, let's take a look at that particular method. toCharArray. And what it does is it converts a string to a new character array. Perfect. And we're going to use the array to actually loop through every letter in the sentence. And again, also important, every letter, space, and punctuation. So now we can do that. We need to think about this though. So our actual program needs to make sure that all of the letters in the alphabet, in the English alphabet, are accounted for. What's the best way to do that? There is a data structure called a set, and in Java we'll use the HashSet, but there's a data structure, and we're already using one now. We're using an array, but another data structure that we can use is called a set. So let's look that up as well. Look up HashSet, and I want you to see what's unique about the HashSet. This is going to make solving this particular problem very easy. Without this problem could be very difficult. So let's look at HashSet, and I'll open this up and then even zoom in so we can see it. Somewhere in here, we're going to look at the fact that it's going to be storing unique values, and it's probably at the actual method itself called add. So let's look at the methods. Here it is. Add adds a specific element to this set if it's not already present. So a set is very useful if you want to store values essentially in an array, just storing values, multiple values, but you want to make sure it's only the unique values. So that's how you can use a set. There's various other methods here as well, but we want to definitely make sure we use the set method, and then we want to potentially iterate over them, or at the very least count them, look at the actual size to see how many values are actually in there. And this is what we're going to do. So what we're going to do is add the letters into our set, and then once we've looped through, once we've gone through all of our letters and punctuation, etc. in the sentence, we want to check to see, are there the corresponding number of letters? 26. There's 26 letters in the alphabet. Are each of those letters accounted for? So that's how we're going to solve it. Let's do that. So we're going to make a hash set of characters. Call it char set. So now that we have that, now that we're using our set, we can add our spaces, punctuation, letters, etc. And I keep saying that because that is going to be important. Let's add everything now to our set, and let's see what we get. After we're done looping through it, let's also print it. So we can see what's in there. Let's compile this. Ah, yes. Okay, HashSet cannot be resolved to a type. I have not written any code to utilize HashSet to actually create an object of, or an instance of an object called HashSet. So let's come back to the documentation for HashSet. This is in the package called java.util. So I'm going to copy this. And if you get a message like this and you're trying to actually use a Java class, and you get this, you probably need to actually import this first. So let's do that. Let's come above our class name, our declaration, and we're going to import java.util.hashset. Compile that, and that will get rid of that error. So now we can use HashSet. So since we didn't write that code and someone else did, what this is saying is import the code so I can use HashSet, and I can use add and size, and the add being only add if there's unique values. I didn't actually implement that myself, someone else did, and it's in the Java language, so here's how I can use it. Let's run it. And we have, in addition to returning true, prior to that we're printing out char set. So we wrote the word test up here, so it's giving us S, T, and E. This is a really good example because the letter T is in here twice, and it's only showing 3 values in here, so we know this is working. What if I wrote this, test this? We have an uppercase letter in here, which is important. Uppercase and lowercase letters. I'm going to compile this. What do you think is going to happen if I do this? Let's run it. Now we have a space as well. So spaces are in here. I'm also going to add a period. Let's compile this. So we now have a space, punctuation, uppercase and lowercase letters. So everything that we needed to account for is in this string. Let's run it. So we have a period, uppercase letter T, lowercase letter T. This is not going to be good for us. What we want to do is find out in our set, in our char set that we've, or in our, let's just call it a set, we want to find out, are there actually 26 unique values in there, but only if it's 26 unique letters. So we need to find a way to get rid of spaces, only account for either uppercase or lowercase. We have to just decide on one, put only that value in there, and also get rid of punctuation. So we have a little work to do still. So why don't we first make sure we only look at letters. Let's do that. Let's bring Google back up. And in Google, we'll bring up character class again. And in character class, there is a method, I believe, called isLetter. Yes. It's static. So isLetter, it returns a Boolean value. The char that we put in, for the parameter, it's going to let us know, is that a letter or not? That's perfect. That's going to exclude spaces, exclude periods, exclamation points, all that. So we solved that. Let's get that on here. So if character, because it's a static method, I don't have to make an instance of it. If character dot is letter, and I said I didn't like this naming here, calling this letter. I feel that would be an issue because in the sentence we know that there's periods, we know that there's spaces. Let's call this something better. Let's call this something like char value. And then let's print out char value here. Or excuse me, add char value here. If this is a letter, char value, I'll copy paste so we can know exactly what we're putting in here. If this is a letter, do something. Only if this is a letter do we want to add this to our set. That will get rid of the punctuation and the spaces. Let's see what I messed up here. I missed an extra paren. Let's compile this. Let's run it. Okay, so no punctuation, no period, and no spaces. We still have our uppercase, lowercase. So we have to pick one. We actually have to pick if this is going to be either lowercase or uppercase. Let's actually just force that. So we'll only add those. We'll only add either uppercase or lowercase to our set. Let's bring Google back up. Back in character, the character class, there is a way to maybe say is upper, or excuse me, to lower, or to upper. Let's find that. Here we go. Let's try to uppercase, or we could try to lowercase. Doesn't matter. We'll just do to lowercase. Converts the character argument to lowercase. Perfect. We'll do that. Instead of adding whatever they give us, so instead of it being a capital T, potentially, or capital P, V, J, we won't use that. We'll actually say character dot to lowercase. We'll specifically convert everything to lowercase. And I feel like I misspelled that. Capital C. Now let's run it again, see what we get in our set. There we go. We have still uppercase T in here, but it's not represented here. We force everything to lowercase. And even though there are 3 T's in here, it's only showing once. So perfect. We don't have any spaces. We don't have any punctuation. This should be doing exactly what we need. Now, we need to make sure, are there actually 26 values in here? Because that will only be letters, and it'll only be unique letters. So let's do this. And we'll print it first. Instead of actually printing the actual set, let's count the size. And we can see that there's 5 in here, so we know this should come back with 5. Compile it, run it, 5, and then true. No spacing, but we can see that that's the 5, that's the number 5, and then true. Now that we have that, we can actually make our Boolean method a little more dynamic. Instead of just returning true, let's return true only if there are 26 unique letters in here. So if we have 26 of these, so if char set has 26 values in it, then return true. Otherwise, return false. Let's compile it and run it. We know this will come back with false because there are not 26 unique characters in there. 5, false. Let's try some of our, what we've at least are pretty sure are examples of pangrams. We'll keep the period as well. Compile that. So this should come back with 26. And true. Perfect. Let's try again. Compile that one as well. Run it. 26. True. And we saw that if we don't have 26, our example before only had 5, but we're taking out a letter here, 25, false. So that's our answer. We were able to use a data set called a hash set. We broke our string down into an array of the primitive data type char. We needed to make sure that we were actually looking at letters, not punctuation, and we had to force our letters to lowercase to make sure our set actually cooperated with us, put a unique value in there. To the computer, the uppercase T and lowercase t, or just any uppercase and lowercase letters, are different. To humans, they're not. So we needed to actually force that upon the computer. We needed to say, look, all the letters should be just the same. So we forced them to, in this case, lowercase. So a capital T and a lowercase t were looked at exactly the same. So we were able to do all that logic and then break it down here. If there are 26 unique characters in this set, then we know we are in fact looking at a pangram. And that's how we solve for the pangram validator.